Okay, we've walked through coding the rectangle class, which describes an object of type rectangle. Now I want to talk a little bit about compiling and testing code. So I am going to provide you with the test code I'm going to show you in a moment as a PDF, not as Java source, not as a Word document. I'm going to provide it to you as a PDF. I don't want you to just lift the code and compile it and execute it. If you're following along and coding along with this, I want you to type the code in for the test harness. We're not going to walk through typing all of it during the video, but that's really good exercise. It's a really good learning experience. I really recommend typing it in and working through it on your own. We're just not going to do that in the video, and I'm not going to make it way too easy for you to do on your own. So let's take a look. We're in our rectangle class. We've just got our instance variables, our two constructors on our null and our full constructor. Full constructor does not directly set anything. It must use the set methods. We've defined our set methods. Public final void for sets, always the name of the set method, always the word set followed by the instance variable name, adjusted for camel casing. One argument of the type that matches our instance variable with a local name. Simply inside our set method, the instance variable is set equal to the input parameter. Our get methods are coded, again, public final, always. The return type is the type that matches our instance variable definition. The name will be the word get, followed by the instance variable name, adjusted for camel casing, and we have an empty argument list always with our get lengths. The keyword return, get methods, our keyword return followed by the instance variable name. In this case with primitives, what we're actually returning is a copy. We defined two additional methods, calculate area, which will return a double. It's public also. In calculate area, we did everything ourselves. Every individual tiny little step we wrote out. This is great. This is detailed. It's easy to read. It would be very hard for someone to misunderstand what was going on. This should be very, very clear to anyone who wants to read it. Another approach, we took a different way to do this in calc perimeter, also declared as public, also returning a double. We have a single statement for this. We're still using the get methods to get access to those instance values. We are allowing the JVM and the heap to manage our intermediate results and to then combine everything into a final result, which we will then use the keyword return to send back to the calling method or process. We defined our toString method. We took a little bit longer road with this one than we did in calc perimeter. We set up our string object. We provided a format statement. We then filled in our placeholders in our format statements by calling the appropriate get methods. Then we returned the string we built. So all of our code for rectangle, while it is not commented beautifully, we have complete code and we can now compile this. Oh, and don't you know, I'm sorry, let me close that. That shouldn't be here yet. We can now compile our rectangle code and we'll figure out what that other thing is in a moment. Couple of comments about the compiler. You'll make typos when you're typing code. The compiler can help you find those. You will occasionally have scope problems. Clicking on either the opening or the closing brace of what you expect to be a scope will help you work those out. Every once in a while, you will find that you have called a method by the wrong name, or you've called a method on an object that does not have access to the method. We're going to talk about debugging later. We're not going to get into that in any great depth right now. But the idea here is this code has compiled. Getting a clean compile for your code, however, does not mean the code will work. It means that there is a certain level of internal consistency in your code. It means that the compiler thinks it knows what you wanted. It does not mean that you have followed standards necessarily. We did here, but that's not a given for a compile. It does not mean that your logic is correct. We could have compiled but used the wrong formulas for our calculations. We could have gotten a clean compile but left off, perhaps, one of these calls to fill our placeholders here. A clean compile is not a guarantee. What I want to do now is go ahead and close this, and actually the problem I saw earlier may be a good thing. I'm going to open the test code I'm going to provide to you. This is very heavily commented. And honestly, this is only a little more comment than I write when I'm writing code just for my use sometimes. You cannot over-comment code. Okay, what we're going to do is test everything in our rectangle class. We want to test both of the constructors. We want to test both of our set methods. We want to test both of our get methods. We want to test calc area. We want to test calc perimeter. We want to test our toString. You want to make sure you're testing every piece of logic involved in your class description. Now, code that does things should have a verb in the name. In this case, the verb is test. Code that works with objects, that processes objects, that asks objects to do things, will have a main method. Go back and look at rectangle. It has no main. Code that describes things has no main, has a constructor. Code that works with objects has no constructor, has a main method. By definition, our main method header never changes. Public static void main open paren, accepting a string array named args. Technically, you can probably name that anything you like, but we'll stick with args. What we're going to do here, we're going to start by simply declaring a rectangle object. We're not building it. There's a difference between declaring and instantiating an object. This statement on line 32 that you're looking at is a declaration. It does not create a rectangle object. It simply sets aside a name and a place for something called SumBox that will be of type rectangle. We have not created anything yet. Line 40 does the instantiation. It's an instantiation when you see the keyword new. New, I am calling a constructor. I am calling a constructor for the rectangle class. I am calling a constructor for the rectangle class that takes two double type variables or values. Okay. When you see the word new, you're calling a constructor. This on line 40, this is the instantiation. We don't have to do that in two statements. Again, we can compress the code. In line 46, we are both declaring a new rectangle object and instantiating it using the null constructor. So this is a combination of declaration and instantiation. We know we're instantiating because of that keyword new. We're going to take a look then at those two objects once we've built them. Before we look at those line 49, let me mention something. When we called the full constructor for rectangle, we also executed the set methods. We executed set length. Our length will be 1.5. We executed set width. Our width will be set to 2.0. Okay, so we've actually, with this instantiation, tested 3 methods in our class, the full constructor and both sets. With this instantiation and declaration, we've tested the null constructor. When we call the toString method on SumBox, we're testing the toString method, and because it calls the get methods, we are also testing the toGet methods. If we're careful about how we structure our testing, we can get quite a lot of it done in a fairly short set of tasks. We're going to call the toString method both on SumBox, that was the one we built with actual values, and EmptyBox, which we built calling the null constructor. Then we're going to do something interesting. We're going to call the individual set methods just to demonstrate that this is how we can alter an object when we need to. We can modify it or update it. So on EmptyBox, which was created with the null constructor, now we're going to set a length and set a width individually, discretely, set that up, make those changes to that object. Then we're going to take another look at the object, that state report. Okay, it was empty here. Now we've modified it. Let's take another look at it. This is going to demonstrate how we can use the toString to watch the modifications being made to an object when we need to modify. And just because I want to check those get methods individually, we're going to create variables of type double, and then we're going to call the getWidth method and the getLength method on SumBox. Another thing I want you to notice, outside of the class rectangle, we have to have a specific object name of type rectangle to use when we call these methods. Outside of the class, we have to explain which object of type rectangle. There could be a whole lot of them, literally thousands. Which of those objects did you want to call that method on? So we'll grab those values and then we'll look at them individually and discretely. Then we're going to create 2 more variables, some area and some perimeter, and we're going to call those calc area and calc perimeter on that specific object so that we can output those values. This is a very lightweight test. Real testing would require more work. This is very lightweight, just to kind of give you a glimpse, a flavor. Now, when I did the compile earlier, this threw an error in the compile. Let's see what that was. Oh, cannot find symbol calc area. Did I spell that wrong? Sometimes that happens. What I would do then is take a look at my rectangle class, and I don't really, oh, look at that. I spelled that wrong. I'm going to make the fix where it needs to be. That's supposed to say calc area. That's what our UML said. I didn't catch that typo earlier. And you notice that this compiled earlier. I want to point that out. Our rectangle class, my rectangle class, compiled perfectly fine earlier with a major problem in it. And we did not see the problem until we tried to test the code. Now that I've fixed that method name, by default, Dr. Java will recompile everything that's open for me. When I say yes, everything compiled fine now. Again, that doesn't guarantee anything. This could still blow up in my face. But at least now I know I can execute this code. So I'm going to scroll back up to the top so we can kind of walk through the results when we get them. And I am going to run my code. Now there's a fair bit of output. I'm going to walk you through it and look at the code that produced it. We're not going to see any output from line 32. That is simply a declaration. We're not going to see any output from line 40. That's the instantiation that essentially completes our rectangle we declared in line 32. We're not going to see output from line 36 because this again is an instantiation and declaration. It doesn't actually send anything to our console. Here's our first glimpse. We're going to see the state report. What exactly does SumBox look like right now? Well, it should have a length of 1.5 and a width of 2.0. I swapped those around just to make life interesting. Length, the first value is assigned as length, the second is width, and that's exactly what our toString tells us. Our second toString is going to look at that object we created using the null constructor. There we are. And look at what we got. The JVM is going to be very kind to us. It's going to say, length and width are doubles. Those are primitives. You may want to do math with that. Let me give you something that will at least let you process to a certain degree. And the JVM will set values for us. This is not true with all languages. It's not true with compilers outside of the Java compilers necessarily. And you might find something different in some Java compilers if they've been extended. But this is a good bet in Java. Java is one of the few languages that gives you this guarantee. As a coder, as a designer, I appreciate that. The next thing we're going to do is modify the length and width of empty box. And then we're going to, on line 57, output that. Right here, empty box now has these dimensions. Then we're going to specifically go and grab the width and length from SumBox so that we can print those out separately, just to double check those two get methods. This is what we expect to see. This is good. The last piece of work we want to do, we're going to run those calculations. We're going to run calc area. We're going to execute calc perimeter on SumBox, and we're going to store those and then output them along with the state report for SumBox. So SumBox, the rectangle object, is 2.0 wide, 1.5 long. The area thereby is 3.0. The perimeter thereby is 7.0. Again, this is a very lightweight test, but it did exercise every single method in our class rectangle. Any test you do must exercise every single method and every single logic path in every single method. We're starting out fairly simple, so our test was pretty straightforward. As we move through the semester and our code becomes more complex and our code takes different paths based on different states of things, our testing must also become more complex and become, well, longer and more detailed. But we'll talk more about that later. Thank you.